So I'm going to speak today about building a strong data foundation for AI. Nothing really cybersecurity related. I have a couple of little tips in there about security and stuff with data, but nothing heavy like some of the other talks. About me, I'm Juan Harrington. I work as a data and software engineer for Omnitech here in Rapid City. We also have an office in Sioux Falls. Been there about 20 years now. I have a master's degree in analytics from Dakota State, and also was in the Air National Guard in about 18 years of analyzing F-16 data. So some of the things I'm going to cover today are listed here in the slide. The first three are pretty brief, and then we're going to get into the main subject, which is the foundation, and then some ethical issues, because that's growing importance with AI. The first one is, what is machine learning and AI? You can see in the little chart over there, they're kind of all related, and we hear about ChatGPT, AI, machine learning, deep data science, deep learning. All these different terms that we hear are kind of interrelated and sometimes get muddied in the water when we hear about them. But they're a lot of the same thing. It's nothing new. AI has been around since the 50s. It was actually brought up at a conference in Dartmouth College in '56. So been around a while. However, with the advancements in computers and GPUs, it's been a lot easier to do a lot of this stuff versus back in the 50s with, computers the size of this room. And it's basically defined as a machine that can do tasks that usually required a human being before. Now the computer can do it. As I said with the chart, we have machine learning, which is actually kind of a subfield of AI. These are all interconnected, but machine learning is just taking different statistical models using computers to do predictions. And then the AI is the part that kind of automates that, makes it act like a human brain, like a human would work. So the growing importance in AI today, it's expected to reach about 267 billion or so by 2027. That's a very rapidly growing field. Everybody wants to get into it, be able to use AI to advance their businesses and even cybersecurity, those types of things. AI is just kind of large, and we hear about it constantly with ChatGPT today. Everyone wants to get on action. The annual growth rate of AI between now and 2030 is about 37%. So annually, you're going to see that kind of growth and getting into AI. PricewaterhouseCoopers estimates that AI technologies could increase global GDP by over 15 trillion by 2030. So you see it's kind of a big deal. What's the role of data in AI? Well, it's, as you can imagine, one of the crucial components in the field. You have to have data to be able to do any of this stuff. It's the set of measurements we use to train a machine learning model. So in AI, we have it's a lot of math. Basically, feed the data into these math formulas and algorithms, and it spits out your answer that you want. It's very dependent on the quality and the quantity of the data that you have for the training and testing. So there's some importance there, and we're going to cover why your quality and quantity is imperative. Now here's some food for thought that we're going to cover. Bad data is costing organizations on average about 13 million a year. And was a study in 2016 by I think Harvard or MIT that stated that the United States as a whole is losing about $13 trillion annually for having bad data. Another thing is time. On average, data scientists that working on predicting these models in AI spend probably 80% of time fixing and looking at the data before they even get to developing models. So it's very time consuming for that part of it. And we've all heard the term garbage in, garbage out. And I'm not sure about you, but I've worked with organizations that have come across this quite recently, where we think we have good data and we use the data we have, figure out what we want to say, and then we call it good data, but it's bad data. We have a typical life cycle when we do machine learning and AI. There's design, develop, and deploy. And it's an iterative approach that needs to be, each one of those happens iteratively and then on the whole. And we're going to kind of cover just the design portion more or less, which is understanding the problem, data gathering, and data wrangling, and what data means to that. So as I mentioned, the foundation is kind of what we're going to go over mostly. And this is our hierarchy that we have. It has to start out with data collection, and then you stack on data engineering, and then we do some data enhancements before we can finally do some reporting and inevitably the AI portion of it. So as you can see, they stack on, and each one kind of like the what's the food one, right? So you have eat your veggies before you can have your meats, right? So the first one, the most fundamental in this step, is data collection. So we have to gather data to be able to do this. And some of the questions are, is it the right data? What is required to solve this problem? And when we do AI, we have to look at those and ask questions on what are we trying to solve? What's the question? What's the problem? And not each one of those are individual. You don't have just kind of the, we look at ChatGPT, you just put in X and it solves a lot of problems. A lot of times you have to go through each problem and run through this scenario.
I'm your clicker, by the way.
Oh, you are?
Yeah, for some reason I disconnected, so tell me where you are.
Okay, go back.
Okay.
Another thing is you have to know if you have enough data. So with a lot of these machine learning models, you need a lot of, like ChatGPT has, how much of the internet does it use to train on? Do you have enough data? Some organizations aren't going to be able to do trillions of rows of data if you just have a couple of years worth. Is it good enough? That type of scenario. Also, how is it collected? How is it stored? That's important to know. And then you need additional data if you don't have enough to be able to augment it. A lot of times in AI, we have private data, our own data, but we go out and get other data like weather-related data, census data, things like that. So that's something. Next.
He shut the power off on that, so.
It is off?
Yeah.
You can blame it.
Oh, okay.
There we go.
Okay.
That'll be easy.
So some collection methods we have is private in-house data. So most people are grabbing data in-house from their different systems, ERP, IoT devices. You know that data. Some other options are crowdsourced data. It's public data. You go out and join the public and gather data with like surveys, that kind of thing. Those can be helpful. Is it pre-cleaned, pre-packaged data? You can go out and buy already prepared data that maybe fits your needs, that are already cleaned and prepared. And then there's also automated collection. You have processes in place that just automatically go grab, maybe scrape websites to get data and you're not really involved in it. Those are things that you need to know about your environment. There's also, with the data, different kinds of structures we have. We have structured, unstructured, and semi-structured data types. So structured is stuff that would be in like a relational database, things that you have in ERP systems, CRM systems, things of that nature. Unstructured are like videos, text. Facebook sometimes is called unstructured because they have different schemas. And then semi is kind of a cross between. So it's good to know what you have in your environment when it comes to the data types. So the next part after you know your collection is dealing with the data engineering side of it. That's the next step in the foundation, and it's another essential part of AI. You know, there's a lot of data being generated daily. In this case, about 328 million terabytes daily. Imagine how much that is, right? So, and there's somewhere around 300 million emails a day sent. It just data is growing and growing consistently. And then data engineering services expect to grow 87 billion in 2025. So what is the role of data engineering in AI? Well, it's involved in the collection, preparing, and transforming the raw data into something that is useful for viewing AI analytics. There's a lot involvement there. It's also building out the storage systems and architecture can hold all that data securely and accessible for everyone. It might involve today with integrating data lakes and data warehouses. That's a growing trend. So some of the responsibilities, there's quite a few here: data collection, integration, cleaning, transformation, storage management, pipeline development, scalability and performance, data security and compliance, monitoring maintenance. So you can see as a responsibility for data engineering, there's quite a few there. Like some of the other talk about budgets and not having enough time with people with training. Mention that, and we see this a lot too, where the last speaker talked about, hey, I need an entry level 5 years with all these skills, right? So there's a lot going on here. With that, we want to know about the data. So what type of data we relevant with, structured, unstructured. How does the data flow from system to system? Is it reliable? So when we do this, we have a lot of work on pipelines, ETL, ELT, if you've heard that term. You know, how's that data getting around? Where is it stored? Is it easy to access and analyze? And then how is it stored? Is it in different formats? Do you have text files over here, databases somewhere else, images, all this different data stored differently with different formats all over this? Are they in different narrow tables or wide? So those are, you know, very important with data engineering to know kind of what is going on with your environment. The third part of the foundation is data enhancement. And that's where we get into preparing and improving the data so it's better for AI and machine learning. We clean it, we make sure it's usable, look at the quality of the data. Because we know in the real world, we have messy data. I'm pretty sure everybody here can attend to somewhere in your environment that has some really bad data. Unfortunately, I see it more often than not. It's just you know how it goes. And this is the iterative approach, and there has to be some feedback loops involved where we go through, monitor, look at the data, and invest time to just kind of go through and clean it. We do data quality checks. So there's a variety of different data types of bad data. There's inaccurate data. So it's just something totally wrong. Your birth date is off, your age is off, your address is wrong, that type of stuff. There's incomplete data. So you have cases where only parts of your address are in there, maybe just the zip code and the city's left blank, that type of thing. Conflicting data, you have multiple systems with the same customer, but two different addresses. So which one of those is correct for that customer? There's duplicate data, which is similar, but you can also have the case of one is United States and the other system that says US. Well, that's which one's right to be able to do some analytics. Invalid data is just totally wrong, and you might have, you know, your age is wrong. How many times you go to Lowe's, they ask for your telephone number, and they just type 9999. That's not really valid. outdated data. If you have stale or old data that's not nearly be valid anymore, it might not help with your AI. If you're trying to predict sales, but you're looking at 12 years ago, that's probably not going to be a good indicator. We know with COVID, a lot of companies didn't have models in place for something like that, so a lot of the predictions are wrong. Some of the common data issues we get into is bias. Humans are prone to bias. They, we're human, we make mistakes. Like I mentioned, if you go into Lowe's, ask for a telephone number, you don't want to give it to them, they might type in all nines. Not the greatest, but that's what they do. Mislabeling, you might have more than one individual that's looking at pills to decide if they're defective or not. Someone might say this is a scratch and this one is labeled as a ding. They're similar, but each human interaction has a different way of looking at it, right? Inaccurate data, again, it's might not be relevant to the problem. So if you're trying to analyze sales, what you're looking at, maybe customer service data, really, in this case, probably, but then you got missing data is a biggie. So you're trying to collect data, all these machine learning, AI formulas, math really require that you have complete data sets. So if you have gaps, what does that do? And then you may have data imbalance where you have unrepresented groups or that are either over or unrepresented. So in the case if you're trying to do fraud detection or maybe predict if someone's going to default on a loan, but the whole data set you're doing, 98% of the training model says you're not going to do fraud, and it's probably not going to come out very accurate. You want to make sure your data is balanced between those. So what is some good data? It has to be accurate, has to be complete, has to be consistent, has to be timely, unique, valid, and like I talked about, I want to make sure that we have accurate data, and then it's not missing anything, and it's up to date. You're not looking at old data. So what we want to do is with those different types of bad data, we want to clean it. We remove duplicates or irrelevant observations. We fix structural errors, so we look at typos, mislabeling, try to standardize. So like addresses, we want to make sure that we have some kind of standardization there so that you don't have some that maybe are ST and others are street. A lot of times we like to use services that will kind of handle that for you, be able to tell you if it's a valid address, get the geolocation so you can use latitude, longitude. That's going to work a little bit better than just zip code or something like that. Look at capitalizations. Yep.
Is this stuff usually a manual process?
Generally it is. So a lot of this process is manually, but there are now with advancement in AI, there are a lot of tools that are AI driven that will help with this type of thing too. So, but it still takes a person to know kind of what the data they're using is, and then have AI help you kind of solve these problems.
Because with security, we use a SIM, and everything you're doing is a SIM. We're pulling in logs from different devices for different applications. We got to go through each log source, figure out what data is in, say, the events that we're getting fed into the database. Okay, so Microsoft Word documents have these characteristics. You go across to another log source like a printer, if you're pulling printer logs, okay, data integrity, what fields match masters and that stuff. We spend all of our time initially building, bringing a new log source. Okay, what data, how much is going to be there, parsing it out. Okay, what crosses over, all these things he's saying for the data, like on a SIM, it's your log sources and the events from those log sources, and then parsing out the data in each individual event. And then building rules to behaviors. That's what we spend all our time doing in sim, is all this that you're talking about. And some is automated, it's getting better. I think it depends on the tool that you implement for the purpose. I mean, you're way different than what we are, but the sim from ours applies all of this. Some of it in different sims do different automations.
Yeah, so it depends on the tool, and they're definitely getting better. I deal a lot in like Microsoft SQL Server, those types of Microsoft tools, and one of the products is master data quality management, and it's kind of a similar thing. You map data coming in, where's the map to, and now on the cloud there's Dataverse and other tools that will go out and look at your data and automatically kind of tell you whether it's PCI type data, if it's an address type data, things like that to help. Unfortunately, you still have to have that person involved to kind of oversee some of it and make sure it's good. But hopefully in the next couple more years, it'll be a lot of fun.
Are there a lot of templates for, I know, like a SIM, you can say this system device, it might be a template for it, or whatever, but in AI,
Unfortunately, it depends on the vendors and how good they're at it. You know, some of it is just totally arbitrary. There's no documentation. So it really depends on the vendors. And if you're doing in-sourcing your own data, how well you're documenting that with some templates, things like that to help. Sometimes you go in and no one knows where their data is coming from, what it looks like, anything like that. It really gets difficult. So you have to, part of it is to go back and build out that documentation. I'll talk about what the two is.
And that feedback loop, like
Yeah.
we're pulling in Microsoft events. Well, Microsoft's cloud, they're constantly improving and changing. So what worked Tuesday, it will not work the next Tuesday for their event logs. And we're constantly going through that and monitoring those events to clean up those.
Yeah. But you might be using some old IoT device that has embedded old Windows on it, and it's feeding you some common element data with no headers, and someone's got to know what that is. Unfortunately. Another thing I do is fix unwanted outliers. You might have some data that just is really skewed. Maybe house sales in the area, and you have, you know, the average is 400 grand, let's say, and you have 3 or 4 houses at like 40 million. Are those accurate? Maybe they are, maybe they're not. So you kind of have to figure that out. Decide if you want to get rid of them. They might dirty junk. And then another biggie is how do you handle missing data? So if you have gaps, a lot of times we just ignore those rows, or we might, if it's just certain fields, we'll kind of infer some data if it's numerical. So what you want to do after that is you want to make sure you have good data. And ways to do that is data profiling. So you start looking at the data, start profiling, do some simple statistics about it, some averages, some charts, just to kind of see what your data looks like, profile it, kind of get a summary of what your data is. Then you want to continually monitor it, because you'll get data drift of, you know, what you get for data today might not be what you're getting in 3, 6, 9 months. It changes. Or if you're using a vendor or IoT device, they might tack on another 2 or 3 fields a few months down the road. How does that affect it? Or they might fix a bug and it changes some of your numbers. So you want to constantly monitor and make sure that that's accurate. And then you want to constantly data clean and pre-process that data so that it's good downstream. You want to establish data governance policies, so especially in regulatory agencies or HIPAA, those types of things. Those are probably a requirement. Other ones you want to try to do this so that you have some kind of practices and policies in place with how you're getting your data, know where the data is coming from, if it's trustworthy, things like that. And then document and create metadata to help you with those pipelines and processes. So, you know, again, go back to data governance, make sure that you know where your data is coming from, how that it's moving from system to system, make sure it's secure, those types of things. And some of the ways you can help with that is create some data stewards in your organization, maybe some subject matter experts for each business department to kind of help you build out some of this documentation and guide you with that. Because you know, if you're in IT, you might not know what the HR data is, what the sales data is. So having those individuals involved is going to help you with that. And then once we get through the first three kind of parts, the biggie foundation, and you have your data clean and it's good quality, then you can start doing some reporting and BI before you get into the analytics side. So here you can start looking at some actionable insights, maybe doing some charting, look at what your sales were last quarter, those types of things. Just get a basic understanding of what your data is today and what was going on in the past before you try to figure out what you're going to do in the future. Get those patterns, trends, anomalies in the data. Create some dashboards, some KPIs, some nice green and red, so your business leaders can see if you're doing good or not. And then once you kind of get that mastered, then you're probably ready to actually hit the AI and deep learning. I know today we hear a lot about ChatGPT, all these different cool AI tools, and you can just paste stuff in there and it's going to answer your questions, but in reality it doesn't work that way. It takes a lot of work to get to this point, and that's where ChatGPT, they spend a lot of money to be able to produce that product, but probably within your organization don't have that kind of dough. So you have to start out with those foundational steps before you can get there. So, I recommend starting with something simple, to do a really short prototype or use case that you are familiar with and try to get a quick win. And then you start building out your AI in your organization. With that though, we're all excited about AI, but there's some ethical implications, regulatory, all sorts of things. Cover a few of those. With that, we got to make sure that when we're building out AI, that we have to emphasize fairness, transparency, accountability, and respect for human values. When we're, just going out and building out AI models, we got to make sure that we're not impacting individuals too drastically. Some of the issues are privacy, bias and discrimination, transparency, accountability, security, and job displacement. So some of the things that might happen is when you're building out AI models, to make sure combination of privacy and security is the data you're using isn't maybe getting leaked out somewhere that shouldn't be, that those models are using them efficiently and they're not being able to get hacked and that data gets taken. With that, then, same thing with security, make sure that your data is secure when you're feeding these AI models. And then there's transparency. With that, a lot of times with the AI models, they're just a lot of math. They're very complex, black box, don't really know what's going on behind them. So you want to make sure that you're able to kind of explain, because your customers and stuff like that is like, how did you get this credit score? I don't know, the AI told me, right? You kind of have to explain that, be able to explain that with your data and be cognizant of what they're doing. With bias and discrimination, this kind of plays into regulatory too, where you're building out the models, but if you're using different data points from different data sets that maybe go against regulations, gender, religion, race, those types of things. You got to be aware of what laws go around that, so that you're not impacting and being discriminatory. Accountability is, if something does happen, who's responsible? If AI, you build out AI model to predict something and something happens, maybe you gave credit to someone that shouldn't, who's responsible when there was a mistake? And then a biggie that everybody's concerned about is job displacement. So, is AI going to take all our jobs? Probably not. In most cases, we see studies where it'll actually create a lot more jobs. And one of the good things is it'll get rid of the tedious work that we don't like to do and allow us to actually do the cool stuff. So it can be scary, but it can be a good thing too. So in summary, within organizations, you want to focus on your data literacy, data collecting infrastructure before you start AI projects. So like I said in the slides, make sure you know where your data is coming from, how it's getting collected, make sure you build out a really good data engineering pipeline where the storage is at, everybody's able to access it needs to. And with that, you want to make sure you know what goals you want to achieve with AI and start with something simple. And then are you ready at this point? Thanks. Any questions?
What projects are you working on with AI right now?
I have a couple different ones. Oh, sure. He asked what type of AI projects I'm working on right now. I have a couple different ones. In reality, though, in most cases, I'm not doing a lot of with AI because with building out this, why I built out this presentation is several of the clients I do work with aren't quite ready. They still don't have that foundation down. So the data is still dirty. It's all over the place in different formats. It's different storage systems. So a lot of what I do is actually build out data lakes and data warehouses to be able to do the analytics from. But the couple that I do work with, one client is kind of a common scenario with length of stay with patients in this case, old folks home, I guess I want to say, but that's what they do is kind of seniors, and they want to predict how long they're staying at residency or emergency rooms, so they can kind of manage that risk and with cost.
Or are you working on the cleanup as well then? So I guess what portion of this do you do? Or you do it from end to end?
We have a group at Omnitech that have different strengths, so we try to kind of come in as more than one person to be able to solve the problem, since strength in numbers, right? So in some cases, I'm doing all that work, but it takes a lot of time. So if we can bring in more people to help and kind of fit where their skills are, that helps. But a lot of times when I'm bringing up like with the data warehouse situation, ground up, it's cleaning the pipelines, the spin up Azure resources, things like that. There's maybe smaller businesses that aren't familiar with that side of it. So kind of varies from client to client. Some of them have a really good IT team and just need some supplement or help getting further down the road.
What do you recommend for a data warehouse? Is that something that you design yourself, or is there something that you?
Sure. He asked what I recommend for using for a data warehouse, or what I use for a data warehouse. So a couple things with that. One is there's a kind of an architecture for it. I do what's called Kimball design. It's a dimensional design. A lot of people are familiar with relational databases, right? Access SQL Server, those types of things. But when you get into data warehousing, it's kind of a different beast. So we're used to, saving storage with a relational database. It's different tables to link together, etc. In a warehouse, it's more flat. It's for analytics, you kind of want it flat. So we build this Kimball design, it's a star schema. So you have like your transactional information like sales and things, what's called a fact table, and then you have what you're going to slice and dice or do lookups, it's called a dimension. So I start with that kind of architecture, and then what you use for like the database engine doesn't really matter. Since we're more of a Microsoft shop, we kind of go towards SQL Server or cloud, Azure, have some in AWS, but mostly it's really with that, you want to hone in on the kind of the logical design before the physical, so that schema that I talked about, get that hammered in, and then you just put it on whatever database engine that works. Some clients, you know, depending on the amount of data, smaller databases where if there's a large amount of data, we're going to switch over to something different, costs are involved, like Postgres. This is free and it does a good job. Other questions?
Juan, is there a place where folks don't have a large data engineering team or that kind of stuff, they can get started, as far as finding information out or, learning more about these type of techniques and stuff?
Sure. Yes, if you're a smaller organization and you're not familiar where some of this information might be, who can help you out. Really for myself, it was, I started out in Omnitech about 20 years ago doing software, but I always was more interested in data side of it. So a lot with IT, right? It's, courses online, Furl site, Coursera, all those types of things, YouTube. That's kind of, where I go most of the time with a lot of those different entities, Google, etc. Books, there's several books out there about, AI, machine learning, data warehousing, those types of things. So self-taught is usually one of the things that we do in IT quite a bit. I went back to school because I was interested in a little more foundation to it than just picking up a book. And then, of course, if you're really interested in Omnitech, we able to we do anything from software to AI. Anything else? Otherwise, if you have questions, you can come down and turn personally or kind of a broad topic and not cybersecurity related, but hopefully you enjoyed it.
Thank you.